You pick up a shovel, you start digging. You go down 1 meter, 2, 5, 10. You are already exhausted, and the planet is just getting started. The Earth is 12,742 kilometers across. The deepest hole humans have ever drilled goes down only 12 kilometers. That is less than 1/10 of 1% of the way to the other side. We live on a planet whose interior we have almost never touched. But for 99% of human history, this didn't exist. No drills, no mines, no way to look below the surface. People assumed the ground ended a few meters under their feet, with hellfire somewhere beyond it. For 300,000 years, your ancestors walked across a thin crust without any idea what was underneath. So what would actually happen if you just kept digging? How far could you go before the Earth itself stopped you? And what is sitting right now under your boots? The answer is hotter, stranger, and more violent than anything you will ever experience on the surface of this planet. Let's start at the surface. The first few hundred meters down are familiar. Dirt, sand, sedimentary rock, roots and pipes and bones. The first thing that starts to change is the temperature. The Earth has a geothermal gradient, which means that for every kilometer you go down, the temperature rises by about 30 degrees Celsius. That doesn't sound like much until you start working at the bottom of an actual mine. The deepest operational mine in the world is the Impossibly gold mine near Carletonville in South Africa. It plunges 4 kilometers below the surface. Workers reach the bottom by a 90-minute elevator ride. At that depth, the rock walls are around 60 degrees Celsius. The humidity is 95%. To keep humans alive down there, the mine pumps 6,000 tons of ice slurry into the tunnels every single day. Without that ice, every miner inside would cook within hours. And this is only 4 kilometers down. The Earth is more than 3,000 times deeper than this. We have not even started. To go further, somebody had to try. And in 1970, somebody did. On the remote Kola Peninsula, in the Arctic far north of the Soviet Union, a team of Soviet engineers began drilling a hole into the ground. The project was called SG-3. The goal was simple: beat the Americans, reach the deepest point any human had ever reached. They drilled day and night for 22 years. Every meter became harder than the last. At 6 kilometers down, they pulled up something nobody had expected: microscopic fossils, plankton, preserved in 2-billion-year-old rock, sitting inside a layer that everyone had assumed was empty granite. The deeper they went, the stranger the planet became. And then the heat started to win. At 12 kilometers, the rock around the drill bit was 180 degrees Celsius. That was almost twice as hot as the engineers had predicted. The rock itself began to behave like plastic, flowing back into the borehole, sealing itself around the equipment. In 1989, at a depth of 12,262 meters, the project stopped. The Earth had won. 3 years later, with the Soviet Union collapsing, the borehole was sealed shut. It still sits there today, welded over, in the empty tundra. Nobody, in the more than 30 years since, has ever dug deeper. The deepest point any human-made object has reached on this planet is still a sealed pipe in the Russian tundra from a project that was abandoned before most people watching this were born. But 12 kilometers is still nothing, because the crust beneath you is much thicker than that. Late in the year 1909, on October 8th, an earthquake shook the Borehole region just south of Zagreb in modern-day Croatia. A local seismologist named Andrija Mohorovičić noticed something strange in his recordings. The seismic waves coming from the quake had split. One set traveled along the surface, the other had bounced back from something deep underground, at a sharper angle, much faster. He calculated where that boundary had to be, about 35 kilometers down. He had found the bottom of the crust, the place where solid continental rock ends and something denser begins. We call that boundary the Mohorovičić discontinuity now, or just the MOHO. The cola team, after 22 years of drilling, never got close. We have never punched through the bottom of the crust. We are still trapped inside the floor. Everything humans have ever measured directly, every gold vein, every diamond, every fossil, every drop of oil, every aquifer, has come out of this one thin upper layer. Beyond it, we have only guesses. Below the moho, the planet stops behaving like rock. From 35 kilometers down to roughly 2,900 kilometers down, the Earth is mantle. That is the largest layer of our planet by far. The mantle is technically solid, but at the heat and pressure it sits under, it flows. Over geological time, it moves like extremely cold caramel. The crustal plates you live on float on this stuff. Continents drift across it. At the top of the mantle, the temperature is already over 1,000 degrees Celsius. By the bottom, it is more than 3,000. The pressure crushes ordinary materials. The minerals down there change structure every few hundred kilometers. Diamond, the hardest material in your kitchen, is unstable in parts of the mantle. Nothing we know how to build could survive a single hour down there. Here's where the story gets fascinating, because the mantle is not the last layer. Below it, 2,900 kilometers under your feet, the Earth becomes something almost no one ever pictures. The outer core. It is not rock. It is not stone. It is liquid iron and nickel at roughly 4,000 to 5,000 degrees Celsius in a layer 2,200 kilometers thick. Try to picture that right now, somewhere below your floor, below your basement, below the deepest mine on the planet. There is an ocean of molten metal thicker than the entire surface diameter of the moon. And it is moving. Currents of liquid iron loop and twist through the outer core like enormous storms. Those currents do something extraordinary. They generate an electric field, which in turn generates the magnetic field of the entire planet. That field is what deflects solar wind. It is what keeps the atmosphere from being slowly stripped away into space. It is the reason there is liquid water on the surface, plants in the ground, and birds in the sky. Mars used to have a liquid metal core too. It cooled down billions of years ago. The magnetic field collapsed. The atmosphere was blown away by the sun, and Mars became a frozen desert. Everything you love about being alive is being kept alive by a roaring layer of molten iron, rotating thousands of kilometers under your feet. And almost nobody on Earth ever thinks about it. And under that, finally, sits the strangest part of all, the inner core. A solid ball of iron and nickel, roughly the size of the moon, sitting at the exact center of the planet. The temperature there is about 5,400 degrees Celsius. That is the same temperature as the surface of the sun. And yet, the inner core is solid. It does not melt. The reason is pressure, the weight of every other layer above it, every kilometer of mantle, every meter of crust, every house, and every ocean presses down on the inner core with a force of roughly 350 gigapascals. That is over 3 million times the air pressure you feel at sea level. At that pressure, even iron heated to the temperature of a star cannot melt. The inner core stays solid because the Earth is squeezing it tighter than physics normally allows iron to be squeezed. You are standing on the crust of a planet whose center is a chunk of compressed sun. And what if, somehow, you could keep digging anyway? What if you had a tunnel straight through the planet, free of friction, free of heat, free of pressure? Physicists have actually calculated this. It is called the gravity train. The result is one of the strangest numbers in classical physics. If you stepped into the tunnel and let yourself fall, gravity would pull you down toward the center, accelerating you the entire way. Then, on the other side, gravity would slow you down. You would arrive at the opposite end of the tunnel just barely. Gently. The trip would take exactly 42 minutes and 12 seconds. And here's the part that breaks your brain. It would take exactly that long no matter where the tunnel led. New York to Beijing, Paris to Buenos Aires, London to Sydney, 42 minutes. Every time. The geometry of falling through a sphere does not care about distance. You would experience weightlessness the entire way, floating inside the tunnel, accelerating through the heart of the planet while the rock around you glowed at the temperature of a star. You would emerge on the other side of the world at your antipode, the exact opposite point on the surface. For almost all of Spain, that point is in New Zealand. For New York, it is in the southern Indian Ocean. For most cities, it is the middle of the sea. Because the Earth is mostly water on one side and mostly land on the other. For 99% of human history, your ancestors walked on a planet they did not understand. They thought the ground was solid all the way down. They thought hell was somewhere underneath. They had no idea that the surface they trusted was a paper-thin lid sitting on a furnace. We know now. We have measured the layers. We have calculated the temperatures. We have pictured the iron ocean and the solid sun in the middle. And we have still only drilled 12 kilometers. The center is 6,371 kilometers below. We have sent probes to Pluto. We have walked on the moon. We have crashed robots into asteroids on the other side of the solar system. We have never opened the door under our boots. The ground is not solid. The ground is a roof. And inside the building, almost no one has ever been. We do not live on the Earth. We live on its skin. Most of the planet we call home is a furnace we will never see. And it has been burning under our feet the entire time we have been here. We have just been too distracted by the sky to look down.